Step into the rings with me.
Why should you come inside? Because it's there.
Take one small step inside to find out more about life on the moon. I got squared away when I made short stuff of that French guy. Can you imagine building Egypt's pyramids with no cranes, forklifts, or trucks, with little more than your bare hands? Some of these enormous stone tombs are almost 500 feet high. In the Great Pyramid at Giza, for example, there are over 2,300,000 blocks of stone. Each block is as big as a large room in a house. The largest are 7 feet high and 18 feet across. It's said that 100,000 slaves labored for 20 years to build the Great Pyramid. Each of the 2-ton blocks of limestone or granite was brought by boat across the Nile River and pulled on sledges along a road from the docks to the building site. Now, as the pyramid grew higher, slaves pulled the stone blocks up ramps to the top. The inside blocks were left rough, but the outside ones were very smooth and even. And the pyramids were so well constructed that you can still see them today if you ever visit Egypt. The pyramids were designed for a special purpose: to preserve the bodies of Egyptian kings or pharaohs. The Egyptians believed in life after death. They thought that their future life depended on keeping the body well preserved. So pharaohs' bodies were mummified and hidden in special rooms below ground in a pyramid. Food and other necessities of life were buried with them. The pyramids were designed with many rooms and false passages in order to confuse would-be grave robbers. Archaeologists think the pyramids were built around 2500 BC. We know for sure that the Great Pyramid at Giza was built by the pharaoh Cheops somewhere around that time. And the Egyptians weren't the only culture to have pyramids. They were also built by people as close as Greece and as far away as Mexico. The ancient structure at Stonehenge is one of the world's great mysteries. What are these massive rocks perfectly aligned to the heavens? Stonehenge, which stands near Amesbury in England, is a structure of upright stones and ditches placed in a circle. The stones are set in 2 circles and 2 horseshoes of upright stones. Some of the separate stones have been given fanciful names, such as the altar stone and the slaughter stone. Some of them feature primitive engravings, such as these daggers and axes. Cremated human bones have been found in pits located around the structure. Legend has it that the stones were magically transported from Ireland by Merlin the magician. But today, scientists know that parts of Stonehenge date back to about 2800 BC. Most now think that Stonehenge was built by the Stone Age and Bronze Age farmers and herdsmen of southern England. It's true that no one knows why Stonehenge was built, although people have been fascinated by it for a long time, and they have come up with several theories. For example, it's known that parts of Stonehenge are aligned so that the midsummer sun rises at a particular point. Some people also noticed that the positions of the stone blocks can be used to measure the movement of the sun and moon and are aligned with eclipses. So they theorized that Stonehenge might be some sort of solar calendar. But what about the cremated bodies in the pits? Was it a religious site or perhaps a graveyard? Most people think that Stonehenge was a sacred enclosure, combining religious, scientific, and social aspects of life in prehistoric Britain. But beyond that, we may never discover the meaning behind the mystery of Stonehenge. Imagine yourself roller skating down the sidewalk or soaking in a hot bath, when suddenly everything stops and freezes, like in a photograph. That's just what happened to the city of Pompeii. On August 24, 79 AD, the southern Italian volcano Vesuvius erupted, covering Pompeii with ashes 18 to 20 feet deep. When water came down on the ashes, the material became like clay, leaving everything exactly as it was before the eruption. Pompeii was forgotten until 1763, when excavation started. Over the years, archaeologists have found remains of entire families going about their daily lives and ovens with loaves of bread still in them. The houses, roads, and theaters, everything is just as it was. By exploring the ruins of Pompeii, archaeologists have been able to arrive at an accurate picture of life almost 2,000 years ago. Did you know that when it's 12 noon in Paris, it's only 3 a.m. in Los Angeles? Well, that's because Paris and Los Angeles are in different time zones. Time zones are based on lines of longitude. As you move east from Greenwich, England, you add 1 hour for every line of longitude. As you move west, you subtract 1 hour. So when it's 12 noon in Greenwich, it's 7 a.m. in New York, 5 lines of longitude away. Time zones aren't set in straight lines, however. That's because individual states and countries choose which time zone they use. On the opposite side of the world from Greenwich is the International Date Line. Cross it going west and you lose a day. Cross it going east and you gain a day. So if you were at the International Date Line on your birthday, you could celebrate one day, cross the line, and celebrate again. Now take a look at this map. By clicking on a city, you can find out what time it is there when it's noon in New York. It's 9 a.m. in Los Angeles. Surf's up. It's 11 a.m. in sunny Guatemala. It's noon in the Big Apple, New York City. It's 2 p.m. in Buenos Aires. Time for a siesta. It's 5 p.m. in foggy London. Oui, say 6 p.m. in Paris. It's 7 p.m. in Greece. Pass the feta cheese, please. It's 8 p.m. in Moscow, comrade. It's 10:30 p.m. in India. Pass the puri, please. It's 1 a.m. in Hong Kong. Time for a rickshaw ride home. It's 2 a.m. in Japan. Do you have a yen to go to sleep? It's 3 a.m. in Sydney, Australia. Good morning, mate. Meanwhile, in New Zealand, it's a sleepy 5 a.m. When one mountain climber was asked why he wanted to risk his life to conquer Mount Everest, his often quoted reply was, "Because it's there." And at 29,028 feet, Mount Everest is the highest mountain in the world, taller than 20 Empire State Buildings piled on top of each other. Sir Edmund Hillary and Tenzing Norgay traveled to the Nepal-Tibet border in 1953 and became the first to conquer Mount Everest. But mountains rise not only from land areas, but also from the bottom of the sea. If you consider the total height of a mountain to include what's under the sea, then Mauna Kea in Hawaii is the highest. It rises 13,796 feet above sea level, but its base is about 16,000 feet below the water. So at 30 to 32,000 feet total, it's even taller than Mount Everest. But Mount Everest holds the title because it's the tallest mountain that can be climbed from base to summit. Would you like to know more? Just click on the map to find out mountains in some other countries. Mauna Kea in Hawaii would be the highest mountain in the world, except that the first 16,000 feet are below water. Above sea level, it rises 13,796 feet. Mount McKinley in Alaska tops off at 20,320 feet. Mount Aconcagua on the Argentine-Chile border is a towering 22,835 feet tall. The tip of Mont Blanc in France is 15,771 feet tall. Mount Kazbek in the Soviet Union rises to 16,540 feet. Mount Kilimanjaro in Africa gets up to 19,565 feet. Mount Goodwin Austen, also known as K2, rises to a majestic 28,250 feet. Mount Everest on the Nepal-Tibet border is the granddaddy of the big mountains at 29,028 feet. Mount Kosciuszko is the tallest mountain in Australia at 7,305 feet. Mount Markham in the frozen Antarctic is a snowy 14,270 feet high. What's the point of all those lines that crisscross the world map? Well, they're imaginary lines which we use to describe the exact location of anywhere on Earth. The lines going east and west are called parallels of latitude, and the lines going north and south are called meridians of longitude. Lines of latitude and longitude are numbered by degrees. The line for 0 degrees latitude is at the equator, another imaginary line which circles around the center of the Earth, like a belt. Every 15 degrees north and south of the equator is another line of latitude. 0 degrees longitude is on a line that goes through the English city of Greenwich. This line is called the prime meridian. Again, every 15 degrees east and west of prime meridian is another line of longitude. To get even more precise measurements, each degree of latitude and longitude is divided into 60 minutes and each minute into 60 seconds. Here's a map showing some major cities of the world. Pick one to find out its latitude and longitude. Los Angeles, California is at 34 degrees 3 minutes north latitude, 118 degrees 15 minutes west longitude. Mexico City, Mexico is at 23 degrees 0 minutes north latitude, 102 degrees 0 minutes west longitude. New York City is at 40 degrees 43 minutes north latitude, 74 degrees 1 minute west longitude. Buenos Aires is at 34 degrees 36 minutes south latitude, 58 degrees 27 minutes west longitude. London, England is at 51 degrees 30 minutes north latitude, 0 degrees 10 minutes west longitude. Paris, France is at 48 degrees 52 minutes north latitude, 2 degrees 20 minutes east longitude. Rome, Italy is at 41 degrees 54 minutes north latitude, 12 degrees 29 minutes east longitude. Moscow, Russia is at 55 degrees 45 minutes north latitude, 37 degrees 35 minutes east longitude. Jerusalem in Israel is at 31 degrees 46 minutes north latitude, 35 degrees 14 minutes east longitude. Johannesburg, South Africa is at 26 degrees 10 minutes south latitude, 28 degrees 2 minutes east longitude. Beijing, China is at 39 degrees 55 minutes north latitude, 116 degrees 25 minutes east longitude. Tokyo, Japan is at 35 degrees 42 minutes north latitude, 139 degrees 46 minutes east longitude. Sydney, Australia is at 33 degrees 52 minutes south latitude, 151 degrees 13 minutes east longitude. Imagine a whirling tower of wind so powerful that it can snatch up cars and carry them for miles. How do tornadoes, those destructive wind demons of nature, get started? Well, a tornado is a special kind of storm where winds circle round and round toward the center of an area of low pressure. A tornado begins with rising air and winds that blow in opposite directions. Now this starts a violent spiraling effect. Then, centrifugal force throws the air away from the center, leaving a narrow core of low pressure in the middle. This low-pressure core acts like a powerful vacuum on everything it passes. Winds up to 300 miles an hour can collapse walls of houses and destroy everything in their path. Most people who live in tornado areas take refuge from the storm in underground storm cellars that keep them safe until the storm passes. Tornadoes are sometimes called cyclones or twisters, and you can actually see the twisting column of air and dust from miles away. In the U.S., tornadoes occur most frequently in the central states, where they travel in a northeasterly direction at 20 to 40 miles an hour. Fortunately, they usually travel for only a few miles and have a fairly narrow path. Even so, tornadoes cause a lot of damage wherever they touch down. Entire towns have been destroyed by big ones. Oh, by the way, in the northern hemisphere, most tornadoes spin counterclockwise. And in the southern hemisphere, they usually travel clockwise. If you've ever felt an earthquake, you know that the trembling or vibration of the Earth's surface can be a pretty scary experience. Earthquakes occur because there is continual sliding and breaking of the brittle crust at the surface of the Earth. A place where two sections of crust move against each other is called a fault line. Sometimes the sides move up and down, and sometimes they move lengthwise. This movement produces an enormous amount of energy, which is changed into vibrations in the rocks, and we feel it as an earthquake. The vibrations may travel for thousands of miles through the Earth, sometimes splitting it with long, deep cracks. Some earthquakes cause a tremendous amount of damage, while others feel no worse than a short roller coaster ride. Large earthquakes are often followed by aftershocks, quakes caused by the first trembler that can come minutes, days, or even years afterwards. Scientists measure the intensity of an earthquake with an instrument called a seismograph. There are two scales of measurement that are used to figure out how strong the quake was. One scale is called the Mercalli scale, and it goes from a small quake, a number 1, to the largest at number 12. The Richter scale, named after its inventor, Charles Richter, measures quakes on a scale that starts at 1 and goes on forever. But every whole number on the Richter scale is 10 times higher than the number before. So a 2-point earthquake is 10 times stronger than a 1-point. And a 4-point quake is 1,000 times stronger than a 1-point. An earthquake that measures 6 or over on the Richter scale is considered dangerous. Have you ever heard someone say that he was in the eye of a storm? Well, it means he's in the center of all the action, just as the eye of a hurricane is in the center of that fierce tropical storm. But the eye of a hurricane is still and calm. not violent at all. It's the rest of the hurricane that's so ferocious. A hurricane is a huge storm 25 to 600 miles wide with winds up to 200 miles an hour and driving rain. The eye of a hurricane is a small area of very low pressure in the center of the column of spiraling wind. The eye is usually about 10 to 20 miles wide, and in the eye, the sky may be blue and there may be only a light breeze. If you were in the eye of a hurricane, you might think the storm was over, until the winds began to blow again from the opposite direction. Has anyone ever said you were in the doldrums when you were acting tired or sad? Well, there really are places called the doldrums, and they're where many hurricanes start. The doldrums are areas in the Atlantic and Pacific Oceans near the equator. They're called the doldrums because air is always blowing upwards in this region, and early sailors were unable to sail in the listless winds. Hurricanes begin when the moist air near the water rises and is replaced by cooler, thicker air which blows inward in a spiral. By the way, hurricane is the name people give to these storms when they start in the Atlantic or eastern Pacific regions. The word comes from the West Indian word huracan, which means big wind. But if the same kind of storm starts in the western Pacific area, it's called a typhoon, from the Chinese word typhon, which is just another way of saying big wind. In 1980, the American volcano Mount St. Helens erupted for the first time in 123 years. It blew out an entire side of the mountain and spread black ash into towns 85 miles away. Volcanoes form because the temperature under the surface of the Earth gets hotter as you go deeper. At a depth of about 20 miles, it's hot enough to melt most rocks. As rock melts, it expands. This liquid rock, called magma, forms into reservoirs under mountains. The magma rises up through the cracks in the earth, and when the pressure becomes too great for the surface rock to bear, it bursts through as a volcano. The crater, the deep hole in the middle of the volcano, is where the opening reaches the surface and the magma spews out. Temperature and pressure at the surface change the magma into lava. Rivers of lava have been known to bury entire cities. Since the beginning of time, legends have been passed along about life on the moon, from Roman gods to the man in the moon. But long before the moon was explored, scientists realized we wouldn't find any life there. This is how they figured it out. The moon has no twilight. 1 minute it's light, and the next minute it's dark. Here on Earth, we do have twilight. Twilight is created as our atmosphere reflects the sun's rays even after the sun is set. So because the moon has no twilight, scientists knew that there was no atmosphere on the moon. Nothing to protect it from the sun's harmful radiation and heat. Nothing could live in that kind of environment. During a moon day, which lasts a full 2 weeks, temperatures soar to 300 degrees Fahrenheit. And at night, which also lasts for 2 weeks, temperatures can get down to 260 degrees below zero. On July 21, 1969, 2 American astronauts, bundled in heavy spacesuits and moon boots, took the first steps on the surface of the moon. From their orbiting Apollo 11 spacecraft, they flew down to the lunar surface in a landing module called the Eagle. The world watched as Neil Armstrong slowly climbed down and planted his feet on the dust and rocks of the moon. These were his words at that historic moment.
It's one small step for man, one giant leap for mankind.
It had taken 8 years and $25 billion to achieve this lunar landing, and it was cheered on by the millions of people around the world glued to their televisions. Minutes later, Edwin Aldrin Jr. joined Armstrong on the moon. The astronauts returned with moon rocks and soil samples, and the one thing that we had waited for eons, a first-person look at the moon. Light travels faster than anything we know, but a Danish astronomer was able to figure out its speed over 300 years ago with little help from Jupiter. Back in 1676, Olaus Remmer was watching as one of the moons of Jupiter passed behind the planet, became eclipsed, and reappeared on the other side. Remmer recorded these eclipses as they occurred over and over. He noticed that the length of time between these eclipses got shorter as Jupiter and Earth moved closer together, and then longer as the Earth moved away again. There was about 17 minutes difference. Well, Remmer realized that when the two planets were far apart, the eclipse's light took longer to get to Earth. That meant that the distance the light traveled was what actually made the eclipses seem early or late. Using the 17-minute time difference and the known distance between Earth and Jupiter, he came up with a rough figure for the speed of light. Olaus Remmer calculated that light must travel at about 135,000 miles per second. In the early 1900s, Professor Albert Michelson determined a more exact speed of light, 186,282 miles per second. So Remmer's calculations were somewhat off, yet it's still remarkable that he came so close without using any modern tools or instruments. But what does the speed of light mean to us? Well, the Sun is 93 million miles from Earth. That's about 8 light minutes away. Now, this means that the light you see right now was sent from the Sun 8 minutes ago and has been traveling through space on its way to Earth for 8 minutes. And perhaps you've heard the term light year. Well, light year is actually a measurement of distance, not of time. If you take the light speed of 186,000 miles per second and multiply it by the number of seconds in a year, we find that light travels 5,880,000,000,000 miles in a year. That distance is a light year. Ever since astronomers noticed a network of what looked like canals crisscrossing Mars, many people have imagined an advanced civilization living on Mars. But when Viking 1 landed on Mars in 1976, it was determined that the canals were only optical illusions. Instead of a Martian civilization, we saw photos of a windswept, rock-strewn, reddish desert. Even the sky was red because of the iron particles in the very thin atmosphere. The atmosphere is nearly 100 times thinner than Earth's, and it's mostly carbon dioxide. We Earthlings certainly couldn't live in that atmosphere, and neither could any other similar form of life. We also learned that Mars has polar ice caps and definite seasons, as Earth does. There's no liquid water on Mars, again because the atmosphere is too thin, and it gets terribly cold there, from a high of 0 degrees during the day down to 150 below at night. Even though Mars is about half the size of Earth, a Martian day is just 37 minutes longer than our Earth day because it rotates more slowly. But a Martian year, the time it takes Mars to orbit the Sun, is almost twice an Earth year. 1 year on Mars is 669 Earth days. If we thought of that in our normal calendar months, each month would have about 55 days. We already know that the Martian atmosphere is thin. A jet plane flying at about 100,000 feet would be in a similar kind of atmosphere, and so would a mountain climber going straight up 20 miles. But because there's so little oxygen in the atmosphere, a person would suffocate in only 30 seconds or so. And if the atmosphere or extreme cold didn't get him, the ultraviolet rays of the sun would. Because the rays come through the very thin atmosphere, they would severely sunburn a human body in just 15 minutes. Saturn is probably the easiest planet to recognize because it's surrounded by those colorful rings. In 1610, when Galileo first noticed Saturn's rings, he thought they were two fuzzy moons. Then, in 1655, Christian Huygens studied Saturn with a better telescope and saw the rings more clearly. There have been many theories about the rings of Saturn, but not until the spacecraft Voyager 1 sent back pictures in 1980 did we realize how complex they really are. The rings seem to have 7 major divisions and hundreds of thousands of subdivisions, like the grooves on a record. They're made mostly of ice in all sizes, from chunks and boulders down to tiny chips, all herded closely together in a narrow band that's less than 1 kilometer wide. Scientists think the rings may be the remains of a moon that exploded, or possibly interplanetary matter that drifted into Saturn's gravitational pull. It's often true that the more we learn about Saturn and the other planets, the more questions we have. For instance, Voyager 1 showed us close views of Saturn that man had never seen before. But now these pictures have got us wondering. One strange phenomenon seen in the Voyager photos were dark, fast-moving spokes in Saturn's rings, changing shape, then disappearing, as if the rings were a great spinning wagon wheel. Another odd thing was a narrow ring that looked for a while as if it were 3 or 4 ringlets braided together. These two curious effects are still mysteries, but perhaps one day you'll be the one to solve them. Most people think that planets are discovered by accident, but scientists actually went looking for Neptune and Pluto, and they were pretty sure where they'd be. You see, we know that planets are pulled, not just by the sun's gravity, but by the gravitational pull of other nearby planets. Armed with this knowledge, 2 scientists in 1846 saw that there was something peculiar about the orbit of Uranus. At that time, Uranus was the outermost known planet, but its orbit indicated that it was being pulled by something even farther away. So they figured out where the unknown planet should be, and sure enough, there was Neptune. But the orbit still looked odd, and Neptune's orbit wasn't quite right either. People started searching for yet another distant planet, and in 1930, Pluto was discovered. Today, some scientists think there may even be a planet beyond Pluto, which for now they're calling Planet X. There are 2 scientific laws that helped people figure out that there were more planets past Uranus. These laws are Kepler's law of planetary motion and Newton's law of gravity. Kepler's law of planetary motion says that planets' orbits around the Sun are not perfect circles. Newton's law of gravity explains that 2 objects attract each other depending on the amount of mass in each object. Mass is how much matter each object has in it. Attraction also depends on how far apart the objects are. The greater the mass, the stronger the pull. And the closer together they are, the stronger the pull. Using these laws, scientists recognized that there had to be something of great mass pulling at the orbit of Uranus. And of course, that mass was the planet Neptune. Did you know that buried inside every seed is everything it takes to sprout a whole new plant? If you split open a large seed, like a bean seed, it divides into 2 pale, thick leaves called cotyledons. You'll also see a tiny white sprout at one end, between the cotyledons. The sprout is the future bean plant, and the cotyledons, which are filled with starch, are the stored food that will nourish the plant. Not all seeds look like this. Some, such as corn, have only 1 cotyledon. Some sprout as soon as they fall from the plant, though most need a rest period, which is usually in the winter. Seeds found in fleshy fruits like apples or tomatoes don't sprout until they're removed. That's because the fruit contains certain substances that prevent them from sprouting. This field might appear to be one of the most peaceful places on Earth. But actually, those plants are hard at work making their own food through a natural process called photosynthesis. Inside each leaf are hundreds of little cells containing many small structures called chloroplasts. Inside the chloroplasts is a green substance called chlorophyll. That's what makes leaves green. Here's how it works. First, the sun hits the leaf and passes through to the chlorophyll. Meanwhile, water is carried up from the roots through the trunk or stem into the leaves and into the chloroplasts. The leaves absorb carbon dioxide from the air and pass it on to the chloroplasts. Sunlight causes the water to separate into oxygen and hydrogen. The oxygen isn't used by the plant and is released into the air. The hydrogen combines with the carbon dioxide to make a kind of sugar. That sugar is the plant's food. Plants can't use all of their food at once, so they use some and store the rest. Plants that store a lot of sugar produce very sweet fruits or sap, like maple sugar. In winter, when the leaves die and photosynthesis can't take place, the plant lives off its stored food until spring. But if plants use their leaves to make food, what are the roots for? Although the leaves are where the food-making process takes place, the roots of a plant are just as important to its survival. The roots absorb water and carry its nutrients to the leaves for the food-making process. So the next time someone tells you that plants get food from their roots, you can tell them they're almost right. The roots bring in some of the ingredients needed to nourish a plant, but the leaves are where the real action takes place. Perhaps you've seen mushrooms pop out of nowhere in your front yard, as if by magic. Well, mushrooms grow from spores, tiny single-cell dust-like particles that shed from mature mushrooms. Each mushroom produces thousands of spores which are carried by the wind. If they land in warm, moist spots that have plenty of food, the spores will grow into mushrooms. The part of the mushroom we see above ground is only the fruit. Underground, a mass of tiny white threads called mycelium grow from the spores and absorb food from the surroundings. At various points, little balls no bigger than pinheads develop. They push upward and break out of the soil into the familiar umbrella shape. Since mushrooms have no chlorophyll, most of them don't need bright sun. In fact, they prefer shady, warm, and wet places. What do mushrooms, mildew, bread mold, and athlete's foot have in common? Well, they're all caused by fungi. Fungi is plural for fungus. There are fungi that produce molds, like bread mold and potato blight. Athlete's foot is also caused by a fungus, but fungi can also be very helpful. For instance, we get the antibiotic penicillin from a fungus, and the yeast that makes bread rise and beverages ferment is also a fungus. But perhaps fungi's greatest job is to rot dead trees and leaves so their minerals and nutrients can blend back into the soil to nourish the growth of new plants. Without fungi, dead trees would just clutter up the forest and the soil wouldn't get nutrients. New trees and plants couldn't grow without the help of the strange little organisms we call fungi. Perhaps you've never heard of Simón Bolívar, but his record of leading revolutions for independence in half a dozen South American countries earned him the name El Libertador, the Liberator. Bolívar was born in Venezuela in 1783, a time when most of South America was under Spanish rule. Though his family was rich, he sympathized with the common people. He was greatly impressed by the freedoms won in the American and French revolutions. In 1811, he and a group of patriots declared Venezuelan independence from Spain, but the uprising was crushed and he fled the country. 8 years later, he led the Colombians to independence. Within 3 more years, he had freed both Venezuela and Ecuador. As president of the union of those countries, called Gran Colombia, he helped liberate Peru. Upper Peru was named Bolivia in his honor. When Gran Colombia fell apart, Bolivar resigned as president. By then, he had many enemies, and he died a disappointed man in 1830. Although he never fulfilled all his dreams, he is considered to be as important to South America as George Washington is to the United States. There are some leaders whose names alone are symbols of an era. Such a man is Napoleon Bonaparte. Napoleon was born in Corsica in 1769. By the time he was 16, he had graduated from the military academy in Paris. When he was just 24, he became a brigadier general in the army and led his men to many victories. Napoleon gained great fame and honor and became first consul or ruler of France. Then, in 1804, he proclaimed himself Emperor of France. During his 10 years as emperor, France was almost always at war. In 1812, Napoleon invaded Russia, but he didn't have enough supplies during the long, cold Russian winter, so his army had to retreat. After losing several more battles, he was finally removed as emperor and was exiled to the Isle of Elba. Napoleon escaped from Elba and returned to fight again. But he lost to the British at the famous Battle of Waterloo, and this time he was sent to the barren island of St. Helena. Napoleon died there in 1821. There were few leaders of the time who could match Napoleon's military ability, and those who could were, for the most part, British. One was Admiral Horatio Nelson, who destroyed the Napoleonic fleet of ships at the naval battle of Trafalgar off Spain on October 21, 1805. This ended Napoleon's power at sea. Nelson himself was killed in that battle, and a memorial statue of him stands today in Trafalgar Square in London. Another Englishman, the Duke of Wellington, defeated Napoleon at the Battle of Waterloo on June 18, 1815. After Waterloo, Napoleon was sent into permanent exile. Even today, when someone speaks of meeting his Waterloo, it means that he is in a situation where he is doomed to be defeated. Nearly 100 years after Abraham Lincoln freed the slaves in the United States, Dr. Martin Luther King Jr. led a civil rights movement dedicated to equal rights and opportunities for people of every color. In the 1950s, and for most of American history, blacks had little chance for good jobs, education, or housing. There were laws keeping blacks and whites separate and denying blacks the opportunities that white people had. Dr. King believed that this needed to be changed. He led blacks and whites together on many marches and protests. Dr. King's many followers influenced Congress to pass the Civil Rights Act in 1964, assuring blacks and other minorities of the rights promised to everyone in the Constitution. In that same year, Dr. King won the Nobel Prize for Peace. One of the most memorable events of the civil rights movement was the March on Washington. In 1963, Dr. King led an enormous crowd of blacks and whites in a massive march on Washington, D.C. to support civil rights and jobs for all. All of the protesters were nonviolent because Dr. King believed that equality could only be reached through peaceful means. 250,000 marchers gathered at the Lincoln Memorial that afternoon and heard Dr. King deliver the now famous "I Have a Dream" speech. The entire world was deeply shocked when Dr. Martin Luther King Jr. was assassinated on April 4, 1968. He was only 39, but he had awakened millions of Americans to the realization that a free country means equal opportunities for all citizens.